Hello students, I am Dhruvajyoti Chakraborty, Assistant Professor in the Department of Mechanical Engineering of Swami Vivekananda Institute of Science and Technology. Today in this lecture video, I will discuss about the 3D printing technology which you have in your subject Advanced Manufacturing Technology with paper code ME702. This video lecture is the part 1 of the 3D printing technology, and I will uh, do more video on 3D printing technology in the upcoming days. So what is 3D printing? Basically, 3D printing is an additive manufacturing technology where a three-dimensional object is created by laying down successive layers of materials. If you want to make anything, there are two basic ways of creating it: additive and subtractive. Casting is an additive process. In subtractive process, you start with something larger than what you need and then you remove everything that's in the way. Example: woodworking, lathe, CNC milling, laser cutting, where you shave away at your material stock until only your finished part is left. If you have a 2D printer, you are adding ink or toner on a perfectly flat sheet of paper. A 3D printer can also make those flat parts, but its unique feature is that it can have details practically anywhere on a part in any orientation. An injection molding machine does make 3D parts, but it's lacking the layer part. A 3D printer is the machine that produces three-dimensional parts using an additive layer-based process. Three-dimensional means you can make parts that are more than a flat geometry. So here three things really define what is a 3D printer and what is not: three-dimensional, additive, and layer-based process. So generally, there are some steps for making a 3D printed object from a CAD or design file. So when it comes to 3D printing an object, a few things must happen. First of all, you have to design the object you would like to print using any CAD software, mostly known as 3D modeling software. It is with this software that you will create your object to the specifications you require. Then this CAD model has to be converted into .stl file, and that stl file is then have to be converted into a G-code file through a help of a slicing software, because a 3D printer doesn't understand .stl file, it only understands the G-code, and then that G-code file is then processed by a 3D printer to make a 3D object. So now what is a slicing? Slicing is a 3D In slicing, basically a 3D drawing effectively translates that 3D drawing into something that a 3D printer can understand and print. Or if you want a slightly more technical explanation, slicing turns digital 3D model into G code that a 3D printer can understand. Slicing software is a necessary element of 3D printing because 3D printers cannot translate a CAD drawing by themselves. 3D printers need the specification of the object you design to be translated into a language which they can interpret. Basic slicing software, or in fact all slicing software, will create paths for a 3D printer to follow when printing. These paths are instructions for geometry, and they tell a 3D printer at what speed to print at for various points and it at which layer thickness. So now comes the most common methods of 3D printing. There are various methods in case of 3D printing, but the most commonly used and day-to-day used and most commonly used in industry, there are 5 methods of 3D printing mainly. First one is FDM or fused deposition modeling. Second one is SLA or stereolithography. Third one is selective laser sintering or SLS. Fourth one is direct metal laser sintering or DMLS. And fifth one is polyjet printing or multijet printing, or you can say 3D inkjet printing. So, in case of FDM or fused deposition modeling, or it is termed as also fused filament fabrication, it is an additive manufacturing process that belongs to the material extrusion family. In FDM, an object is built by selectively depositing melted material in a predetermined path, layer by layer. The materials used are thermoplastic polymers and come in a filament form. FDM is the most widely used 3D printing technology. It represents the largest installed base of 3D printers globally and is often the first technology people are exposed to. A designer should keep in mind the capabilities and limitations of the technology when fabricating a part with FDM, as this will help him achieve the best result. So in this video you can see how a FDM technology or a FDM 3D printer can 3D print any object that is provided in the CAD file. So how a FDM 3D printer works? Basically, a spool of thermoplastic filament is first loaded into the printer. Once the nozzle has reached the desired temperature, the filament is fed to the extrusion head and in the nozzle where it melts. The extrusion head is attached to a 3-axis system that allows it to move in the X, Y and Z directions. The melted material is extruded in thin strands and is deposited layer by layer in predetermined locations where it cools and solidifies. Sometimes the cooling of the material is accelerated through the use of cooling fans attached on the extrusion head. To fill an area, multiple passes are required. When a layer is finished, the build platform moves down and a new layer is deposited. This process is repeated until the part is complete. So these are the common FDM materials, that is ABS, acrylobutadiene styrene, PLA, polylactic acid, nylon, PETG, TPU and PEI, and these are the various characteristics of the various materials that are used in FDM 3D printing. Next, that is SLA or stereolithography. So basically, a stereolithography is an additive manufacturing process that belongs to the VAT polymerization family. In stereolithography, an object is created by selectively curing a polymer resin layer by layer using an ultraviolet laser beam. The materials used in stereolithography are photosensitive thermoset polymers that come in a liquid form. Stereolithography is a famous for being the first 3D printing technology. Its inventor patented the technology back in 1986. If parts of very high accuracy or smooth surface finish are needed, then stereolithography is the most cost-effective 3D printing technology available. Best results are achieved when designer takes advantage of the benefits and limitation of the manufacturing process. So stereolithography has many common characteristics with DLP or digital light processing and another VAT polymerization 3D printing technology. For simplicity, the two technologies can be treated as equals. So how a stereolithography 3D printer works? How a stereolithography 3D printer works? At first, the build platform is positioned in the tank of liquid photopolymer at a distance of one layer height for the surface of the liquid. Then, a UV laser creates the next layer by selectively curing and solidifying the photopolymer resin. The laser beam is focused in the predetermined path using set of mirrors called galvos. The whole cross-sectional area of the model is scanned, so the produced part is fully solid. When the layer is finished, the platform moves at a safe distance and the sweeper blade records the surface, and the process then repeats until the part is complete. After printing, the part is in a green format, not fully cured state, and requires further post-processing under UV light if very high mechanical and thermal properties are required. The liquid resin is solidified through a process called photopolymerization. During solidification, the monomer carbon chains that compose the liquid resin are activated by the light of the UV laser and become solid, creating strong, unbreakable bonds between each other. The photopolymerization process is irreversible, and there is no way to convert the SLA parts back to their liquid form. When heated, they will burn instead of melting. This is because the materials that are produced with SLA are made of thermoset polymers as opposed to the thermoplastic that FDM uses. So these are the most common SLA materials that we use in our day-to-day usage. The standard resin, clear resin, castable resin, durable resin, high temperature resin, dental resin, and these are the characteristics of the materials that are used in SLA printing. So for today's lecture, this FDM and SLA technology I have described. In the part 2 of the lecture, I will discuss about the rest of the 3D printing technologies. So thank you for being with me. Hope you have liked the video.